Guys, welcome to Bob Teaches Tech. We will get the best of automation and manufacturing content. Here is a robotic arm or an industrial manipulator training device in which we'll document the programming process of this robotic arm. Without wasting much time, let's get started. If you are new to the channel, be sure to subscribe. To start off with this program, we need to create the I/O distribution table or the I/O connection table. For the I/O table, we have SQ. The SQs are the magnetic reed switch and the sensors to which each cylinder of the robotic arm is connected. And we have the start button which is connected to X0, stop button which is connected to X1, and the reset button connected to X2. Each stop button is connected to X4. For the outputs, we have the YVs representing the solenoid valves, and each solenoid valve is connected to their respective outputs. So without wasting much time, let's get started with the program creation. Here we are in a blank page. We want to start off with our program creation. We need to first identify that we want our e-stop to be able to turn off every other aspect of the program. So from our address, our e-stop, we'll put it as a normally open contact. Let's start it off with a normally open contact X004. Then what we need to add here, we need to start off a blinking circuit M813. Provide a 1 second blink, then a condition. This will blink the yellow light. You can add a condition here, then M0. For M0, our M0 here will turn on our yellow light. This for the reset. We will identify the I/O later on. This condition, I will get back to it later. This is a condition just to be able to control M0. Okay, for the next challenge, we'll have to add the input. Okay, the next input will add an input here so that it can be able to control. This will be X. This is the reset button input X002. So this is the e-stop, then the reset button. The reset, what reset will do, we can say you can add it to set something like maybe set M1, so that we can use M1, the condition of M1 to control our inputs or outputs. So for the M0, we'll want the yellow light to only blink to allow the reset to be pressed. Once the reset is pressed, the blinking should stop. And once the reset is pressed, the blinking should stop. And that's where this condition comes in. This condition, we can add a normally we can add a normally closed condition of M1 so as to act oppositely with the on value or the true value of M1. So what will happen here is that once the e-stop is pressed, the M800 is a 1 second timer. 1 second timer will allow blinking for 1 second, and this condition will be on to power on or to change the condition of M0 to be true. And once M0 is true, the yellow light resets. The yellow light is on, blinks. The output of yellow light is Y00, not Y00 but Y17. This is the IO to which yellow light or the yellow bulb is connected. We can now move on to the green light or the start button before adding the condition or the processes in which the yellow light or the reset button will do or will give an output. Button, the address is X00, which is the start button. Then what we need to start here, we can decide to set a value M, an internal relay M, set M2, and once M2 is set, we can use start output to power our green M2, to power our green light. We will want to add a condition here so that the green light will blink if there is no object at the start point. So we'll add a condition here, then our green light. Our green light is Y50. We'll add a condition X17. This is the optical sensor to detect the object. Okay, there are some changes that we can make so that this thing can run, or the program can run efficiently. We need to change the green light, or we need to have the green light blink when there is no object, then bring a constant glow when an object is detected. So what we can do here so that it can work that way, we can decide that once the object is detected here and M2 is pressed, we can decide to set a value that will later turn on the green light. Okay, let's do that. The value we can set maybe M3. Let's set M3. Yeah, let's set M3 and do away with this. Then for our M3 is going to turn on our green light. It is Y00, Y15. Y15. To make the green light blink, we'll only make the green light blink when the reset is pressed, X2 is pressed. So M1 should be able to make the green light blink, but at the same time when M2 is activated, the blinking should stop. So what we can do to effect this, we can add another branch here. Okay, it's not it doesn't follow any sequence, but we can add another branch here to effect this. So our reset output was M1. We can use M1. Then with a condition, and normally closed condition of M2, so that the program should not work simultaneously. So M2, then M8030, the 1 second timer. Then our output has M4. Then the M4 we can use it as an OR of the green light to allow blinking. At the same time, it can allow the on value. So this is the output we will use for our start, to start the whole process. So without wasting much time, let's get to testing it and writing it practically. So here is our programming station, where we are going to load the program we've just written by hand. And as you can see, this is the GXWorks2 software. Hello, so we are here, Melsoft GXWorks2, the program in which we use to load the program we intend to run the robotic arm with, the one we wrote down. So we can start off with our install button. That's a normally open contact, X4, and the timer M8013, 1 second timer. As you can see, it's blinking. Then the condition M1, M1 as a normally closed contact. Then M0 as our output. Then M0 is supposed to be our input for the yellow light, which is Y17, connected to Y17. And then we can insert another line top, then you can deploy it. That can write the program we explained earlier. X2, our reset button, we set M1. We need to set M1, set M1. For setting, we use the application instruction, which is found here, F8. I'm using shortcuts, F8. Let's insert another drop so that you can add the start button. Add the start button, X0, set M2. Remember, we are just following the program we just wrote by hand. We're just following the program we just wrote. And as we continue, add M2 condition, X17 normally open, X17 normally open, X17 normally open, should set M3. M3 to normally open. She will turn on the green light 5:15. And 4. And this M4 can add another 9 set of heartbeat so that we can number the cross time to maybe 30. This is to allow the green light to blink. And this is the program we had written so far. Let's convert it. Go online, not online, but compile. Yes. Let's do this. Let's there seem to be a problem. There seem to be a problem with the program, but we can just do it manually. And now we are loading the program to the PLC. We are writing it. Close that. You can go to monitor mode and see how it behaves. Once we've turned the PLC to run mode, we can see that the yellow light is blinking according to our program, and when we press the yellow light, we can see our start button blinking. We need to put our start button to be able to blink when all the processes have reset to its initial position. So join us in our next video as we'll be documenting how we can reset this robotic arm to its initial position and get the process going. Thank you for watching, and if you haven't subscribed yet, please make sure you are a subscriber. If you like the content, be sure to press that like button and ring that bell icon so that you never miss out on any of the contents of this series. Thank you.